Alright, before the video cut me off, we were about to do the point 2, 2. So this is our x, this is our y. I graphed the point. I know it looks like it lies on one of the circles, but I just drew the circles sloppy, so don't trust them. So let's actually solve for what the angle is, because we're looking for this theta, even though we know that the x is 2 and the y is 2. So for our theta, we've got, I'm choosing to use cosine. If you'd like to use something else, you can. We've got cosine theta equals x over r. So x is 2, but r, to me, we've got two side lengths to the side. I can do Pythagorean theorem, or I can know that this, since they're the same, this is a 45, 45, 90 triangle. So this has to be 2 root 2. So cosine equals r over x, or x over r, sorry. So this is 2 root 2. So if I simplified that, that looks like 1 over root 2, which if I rearranged that, it'd look like root 2 over 2. So now I'm wondering, where does cosine theta equal root 2 over 2? Well, in that quadrant, it happens at theta equals pi over 4. So I know theta is pi over 4, and my r is that radius that I found, so it's the 2 root 2. So for my 4 points, I know one of them is going to for sure be 2 root 2, and then a positive pi over 4. And then I need all of the other ones. So I need another positive 2 root 2, I need a negative 2 root 2, and another negative 2 root 2. So if I'm going in the positive, if I'm starting on the positive side, and then I loop all the way around to that pi over 4 in the negative direction, I'm going a whole negative 7 pi over 4. If I start in the negative section, and then I go in the positive way all the way around, I'm going to have positive 5 pi over 4. And then if I start at negative 2 root 2, and then I go in the negative direction, I'm going to end up with negative 3 pi over 4. So that is how we convert from rectangular to polar. So first, I would maybe sketch it out, find the radius. They're not necessarily always 45, 45, 90, so you can use your Pythagorean theorem. And then you could use cosine, sine, or tangent to find what that angle is. All right, almost done. So just some kind of funny looking graphs. I don't know if we'll ever actually see these again, but if we were asked to graph r equals 3, well, r equals 3, 1, 2, 3, is here, but it's everywhere on the unit circle now that r is 3. So that would just be the graph of the circle with a radius 3. Whereas if I had theta equals pi over 4, I know theta equals pi over 4 here, if I'd started in like the positive r, but if I started in negative r, my positive pi over 4 would be right here. So it actually would just be this straight line. So that would be my pi over 4. Moving on. So now we're going to convert polar equations into rectangular form. So my goal is to try to use those conversions that we wrote down earlier to try to make r's and thetas disappear and have only x's and y's left. So here I've got r equals 3 cosecant theta. So that doesn't look helpful yet, but I know cosecant is the same as 1 over sine. So I'm going to rewrite it as r equals 3 over sine theta. And then I don't like fractions, so I'm going to try to multiply that over. So now I've got r sine theta equals 3. So r sine theta, I know, is what y is. So I'm going to replace that with y, so y equals 3. So I've now converted it from polar into rectangular. If I graph the line y equals 3, that is like right here. So this one, if it asked me for the shape, you could say it was linear. For the next one, very similar. Maybe try it first, then watch the video. So I could change secant into 1 over cosine. So I've got 5 over cosine theta, multiply over the cosine, so r cosine theta equals 5. R cosine theta is the same as x, so x equals 5. So I've now converted it from polar into rectangular. So that would look like a line over here at x equals 5. So this one as well is linear. The last one on this page looks a little interesting. I'm going to try doing the technique of just getting rid of the fraction, so I'm going to multiply this by the r. So I'm left with r times 3 cosine theta plus 4 sine theta. equals 2. And if I distribute the r to both of them, I've got 3r cosine theta plus 4r sine theta equals 2. So we have r cosine theta and r sine theta, and we know that r cosine theta is x, so I'm left with 3x, and r sine theta is y equals 2. So we have changed all of the r's and thetas into x's and y's, and this also makes a straight line, so this would also be linear. Once you get into a form that, like if we're going from polar to rectangular, as soon as you get all the cosines and thetas, or all the r's and thetas to disappear and you're left with just x's and y's, you can stop, and that's a good place to end. The very last problem I want to look at today, my thetas look a little bit weird, but I was having trouble typing. I'm wanting to convert this one from polar into rectangular. So I don't have a fraction, so it looks a little bit odd. But the way I'm going to approach it is I'm actually going to multiply both sides by r. So I'm going to multiply this side by r and this side by r. So I'm left with r squared equals 5r sine theta plus r cosine theta. Based on my conversions that we wrote down earlier, r squared equals x squared plus y squared. And r cosine is y, r cosine is x. Maybe you remember from previous classes that when you have an equation with x squareds and y squareds and x's and y's, that's going to make a circle, most likely. So you could stop right here. In the homework, I showed how to actually turn this into a circle equation because the book asks you what shape they're going to make. So I'm going to show that to you here, but on a test, you could leave it in this spot. As soon as you're in x's and y's and you no longer have any polar aspects, you can leave it like this. However, if you wanted to make it into a circle, a reminder on how to do that. I'm going to move all of the x's and y's to the left side. So I'm going to have x squared plus x. We're going to have to do completing the square, so I'm going to write plus blank. And then my y's, we have y squared. Ooh, I already messed up. Let's do minus. This should be a minus x. This should be a minus 5y plus blank. And then equals, those blanks, you're going to have blank plus blank when we do completing the square. So reminder on completing the square, we should do b divided by 2 squared. So here we've got negative 1x divided by 2 squared. So we'll have 1/4. And over here we'll have 1/4. And then here we're going to have 5 divided by 2, negative 5 divided by 2 squared. So we'll have 25 over 4. So we're adding 25 over 4 over here. So for my circle, I'm left with, if I factor this, we'd have x minus 1/2 squared. This is the whole point of completing the square. And then y minus 5 over 2 squared equals 26 over 4. So kind of awkward, but this now is in a circle formula. So on the notes, or like on the homework, if you look at my key and you're wondering what I'm doing, that's the process. But on a test, you could just leave it like this. All right, I think those are our notes for today. If I was there, I was going to do whiteboard practice with you. So if you would like to do extra practice, I'm going to show you slides and you can pause it and then do the key. So here's your first slide of practice. If you want to try these, then pause it. Then here's the key. So check your answers, pause it. Here's the next slide of practice. So you can pause it. Then here are the answers. You can check those. Then another slide of practice. You can pause it and check your answers. I think that's it. Yep. Okay, so congratulations on having your first day of polar done. I will see you next week, and have a great weekend.